In this video, we're going to talk about how to perform operations on complex numbers given in polar form. So as you can see here, there's a product that's going to be found, there's going to be a quotient, and also there's going to be a power of a complex number. So the first thing that you want to do, 20 times 2 is equal to 40, right? So we know that. We can write a 40. Now, the good thing about the multiplication and division is that we can adhere to standard rules with the exponents, right? So meaning that we're going to basically have the single e raised to the I, and then we're going to add the respective angle measures here, okay? So what that means is that we're not going to add the i's together, but we're going to add the angle measures here. Okay, so 4 pi over 3 plus pi over 2. Okay, so what that gives us is 40e to the I 11 pi over 6. Now keep in mind that this result is only valid when the theta, or the argument, lies between 0 and 2 pi. Normally, when you're talking about polar representations of the complex numbers, you also mainly focus on intervals from negative pi to pi. Right? So when it comes to negative pi to pi, we will have this result, or 40e to the I times negative pi over 6. Now, why negative pi over 6? Because when we're talking about the interval of negative pi to pi, this will correspond to the same position. Okay, this will be the same angle position as the 11 pi over 6. Right? Because 11 pi over 6 will fall outside of the interval from negative pi to pi. So what this equals to is basically 40e to the negative I times pi over 6, right? If you just let it look simpler like that for the interval for the argument from negative pi to pi, okay? So this is a different result. Now, in the second example, the division follows the same rules. 20 divided by 2 is 10. So we will have 20 over 2 e I, and then we're basically going to subtract the bottom angle measure from the top one, right? So 4 pi divided by 3 minus pi over 2. So what this should give us is 10 to the e to the I. Now, 4 pi over 3 minus pi over 2, so basically the LCD is 6, so you're going to have 2 times 4, which is 8. So 8 pi minus 3 pi over 6. Right, so what that should give you is 10e to the I 5 pi divided by 6. Now keep in mind that this holds for both types of intervals, from 0 to 2 pi or from negative pi to pi, because 5 pi over 6 happens to be in both intervals, right? So we don't need to indicate for which one it's going to work. It's going to work for both. Now, in the final example, we're talking about finding a power of a given complex number. Now, we have to find a power in polar form format. Okay, polar form format. So, in polar form, notice that we're going to use DeMoivre's theorem here. Z to the n is equal to r to the n times e raised to the power of I n theta. Right, so there are products for the e power. So we can use that, but first we need to find the r, the modulus of the complex number. So first, to find the r, we should realize what this means. So this corresponds to point 1, negative 1, right? This is a geometric point corresponding to the point drawn in the complex plane. So 1, negative 1, and this corresponds to x and y points, respectively, right? So we know that the r, we can actually find the r. The modulus is going to be basically the square root of the squared components, x and y, right? So 1 squared plus negative 1 squared. So this is going to be what? This is going to be radical 2. So now we have to square the modulus. We have to raise it to the power of n. N in this case is 5. So I'm going to make it green. So n in this case is 5. So we have to raise to the 5th power the radical 2. So radical 2 raised to the 5th power. And then we're going to have e to the I times n, which is 5. Now we need to find the angle theta, right? The argument of the complex number. How do we find that? We need to realize that we can find the theta by simply recalling that the arctangent, first of all, notice that this position of this point, 1, negative 1, is going to be in quadrant 4. Okay, this point. So quadrant 4. So we have to orient ourselves on quadrant 4. And we know that y divided by the x, the arctangent of it, will give you the argument, or the angle theta. Right? So in this case, y is equal to negative 1. So we're going to be talking about this. And that means arctangent of negative 1. Now, arctangent of negative 1 can be either 3 pi over 4 or 7 pi over 4. Now, which one are we going to choose? We're going to choose 7 pi over 4 simply because it's in quadrant 4, as we decided using that point. Right? So that means we have to multiply this, the theta here, as a result will be 7 pi over 4. Okay, so 7 pi over 4. So now we have to simplify this so that it's going to be a simplified polar format. So radical 2 raised to the 5th power. If you raise it to the 4th power, you will get 2 times 2, right, which is 4. And there's one more radical 2 which accounts for the 5th radical 2, right? So it's going to be just 4 radical 2. Now e to the I, and what is going to be the simplified angle theta? So here we have to perform a product, right? So 5 times 7 pi over 4 is going to be 35 pi over 4. And now we have to make sure that it's within the limits of 0 to 2 pi, or from negative pi to pi, right? Ideally it should fit in both. So to do that, notice that if we subtract 8 pi, it will give us the desired position, which will fit both negative pi to pi interval and also from 0 to 2 pi interval, right? Because negative 8 pi, the LCD is 4. 4 times 8 is 32, right? 35 minus 32, bingo, that's going to work, right? So it's going to be 35 pi minus 32 pi, and that result will be divided by 4. So that should give us 3 pi over 4. As you can see, 3 pi over 4 fits both of these intervals, from 0 to 2 pi or from negative pi to pi, right? So it's ideal. So that means we have to have that angle written in here, 3 pi divided by 4. Okay, so we've successfully found the polar form. Okay, this is the polar form. Polar form representation of the complex number. Now we have to also find the rectangular form. Okay? Now the rectangular form, as you should remember, the r value is the same, so it's going to be 4 radical 2. That doesn't change. And then it's simply cosine of the final angle, which is 3 pi over 4 plus I sine of 3 pi over 4. So what that should give us is 4 radical 2 times cosine of 3 pi over 4 is negative. It's minus radical 2 over 2 plus I sine, well, I'm going to find the sine, which is sine of 3 pi over 4 is positive radical 2 over 2. All right, so the final answer to this, notice that the force with the 2's will cancel out. The 2's will cancel out with that 4. It will be a 2. The radicals, 2 radical 2's will give you a 2. So as a result, this will be 2 times negative 2, which will give you negative 4. And then this will be a positive version of that, except it will multiply the I, right? So it's going to be plus 4I. So as you can see, this is the rectangular or the standard form representation of the power of the complex number that we just found. Okay, so I hope this was helpful. Thank you so much for watching, and I'll see you in the next video.